All right, so in number 1, it says if a is equal to 5 times the square root of 2, and 2 times a is equal to the square root of 2x, what is the value of x? Well, so I wrote down 2a equals the square root of 2x. All right, now when I look at this, I notice I have 2 unknowns. What value do they want for me? They want x, actually. They don't want a, they want x. All right, so I'm going to replace a with 5 times the square root of 2. So 2 times
That's 10.
5 times the square root of 2. We're going to get there, yes?
5 times the square root.
All right, so 2 times 5. I see it, Nicholas. You're wasting your own time. Equals 10 times the square root of 2. All right, Marina, get to your seat. Get to your seat. Let's go. What are we doing? Come on. Wasting my time. Now, you'll notice this says the square root of 2x. I want that radical to go away. How do I get it to go away? Square both sides. So I got to square everything. Okay? When I square the right side, that square root goes away. I get 2x. Now be careful on the left side. Do you see how the 10 is not in the radical? So when you square 10, what is 10 squared? 100. Very good. All right, that's 100. And then the square root of 2 squared is just 2 with no radical. So that becomes 200. And now we don't have a radical, so we can just divide both sides by 2 to get x is equal to 100. I'm not lying. That is the answer. X is equal to 100. Sergio, shh. Take out your packet from yesterday, Sergio, so you can write down these notes here. All right, you're already 1 question behind, Sergio. Let's go to number 2. Stop talking about stuff that's not important. Guys, I don't want to hear it. If you have a question, ask. Otherwise, no talking. We have a test tomorrow. Let's get ready. The first one, the only one we've done, is 100. Number 2. Number 2 says, what are the values of x that satisfy the given equation? Now, I notice that the radical is isolated. The radical is isolated. So I can go ahead and square both sides. All right, when you square the square roots, that becomes 4x. Now here's where the most of the mistakes are made. Right here, most students messed up right here. This is x minus 3 squared. So you're going to do x squared, which is x squared. You're going to do x times negative 3, which is negative 3x. And then you double it, which is minus 6x, because you double it. Don't square it. Double it.
Why do you do that?
I'm just doing this to expand this binomial. Negative 3 squared is 9. If you don't know what I just did or am doing, then you should do this. Right? This is high school. I'm trying to show you in college what we do. Okay? Multiply these two together, Carlos. You get negative 3x, and then you double it. That's the middle term, always.
Always squared.
To get 9. Always, yes, that's how you expand a binomial. Okay, so do you see how the x squared is positive on this side? So I'm going to leave everything there, but move the 4x over with subtraction. All right, so it was negative 6x. I'm subtracting 4x. So it's actually going to be negative 10x, Dominic, because they're both negatives, right? Negative plus a negative is still a negative. Okay? So now I need factors of 9 that add to negative 10. They both need to be negative 9, and negative 1, right? Because when you multiply them, that should be positive. A negative times a negative is positive. But a negative plus a negative is still a negative. All right, so what are my 2 answers?
9 and 1.
9 and 1, very good. All right, but be careful. All right, when you do this tomorrow, make sure you always plug them into the original. All right, always into the original. So if we plug it into the original, we have the square root of 4 times 9 equals 9 minus 3. Well, what's 4 times 9? 36. What's the square root of 36? It's 6. 9 minus 3 is 6. So that one works. So 9 works. Let's try 1. The square root of 4 times 1 equals 1 minus 3. What is 4 times 1? The square root of that is 2. But what's 1 minus 3? Negative 2. That doesn't work. 2 is not equal to negative 2. So only 9 is the answer. So it's 2 only. Yes? And I guarantee you'll have to do one of these tomorrow. I square both sides? Yeah. Yeah, if you need to do that. Like, if you need to do this, Camilla, you would, excuse me, Nicholas, you would distribute this and get x squared minus 6x plus 9. I don't need to do that, so I don't do that. I expand this in my head. And so if you need to do it, then go ahead and distribute every time it's squared. Okay? Absolutely. Multiple times, multiple ways. Number 3. Yes, I'm not trying to mess with you, right? This is important. It's on the SAT. It's got to be on my test. Number 3 says, if x is 9 in the equation above, what is k? So all I did first was I replaced x with 9. Let me see that first step. I replaced x with 9. Are we good? So is the radical isolated? No, it's not. So how do we isolate the radical? No. We got to do wait till it's isolated. Move the 9 over. It's a minus 9 here. So when I move it over, it's a positive 9. Now it's isolated. So what can I do to both sides? No, it's already unsquared. Square both sides. All right, you get rid of it by squaring both sides. So now you have k plus 2 is equal to 81. So k equals 79. C. Now, we're about to do number 4. Number 4, I'm sorry, I'm ready to go ahead. We're about to do number 4. Now, number 4 is very challenging. And I don't expect you to understand all of the steps that I'm going to do, but I do expect you to do the very beginning of it, because that will be on the test tomorrow. Okay? All of these are in some way on the test, yes. Number 4. Now, number 4 says, which of the following is equivalent to 9 raised to the 3/4 power? So this is called a rational exponent when it has that fraction as an exponent. So you need to know how to do this. You need to know how to write the radical of 9. Just wait. The radical of 9, what's going to go here on the index? The 4. The denominator is, stop saying the letter. The denominator is the index. Everyone see the denominator? Jacob, the denominator is the index. Okay? And the numerator is going on the outside. Notice the 3. It's cubing, right? Okay, so if you look at your answer choices, that's not there. All right, but is everyone good? Come on. Does everyone see how to go from here to the radical? You will have to do that tomorrow. So make sure you know how to go from this to the radical. Okay? So here's how you go from here. And this is a little confusing. So the first thing I would do is write that 3 here. So I'm going to see how I wrote the 3 on the inside. Those are the same thing. You can do that. Okay? I'll accept both tomorrow. If you write this or this, I'll accept both tomorrow. All good. Okay, so then I said, all right, what if I change it to be like this? Everyone see I still have the same stuff? There's 2 9s here. There's another 9 here. So how many 9s is that? That's 3. So I haven't changed it. Now what's 9 squared? Very good. Do you know the 4th root of 81? Do you know the 4th root of 81?
Oh, wait, no, 9.
It's not 9. Good guess though. It's 3. The 4th root of 81 is 3. 3 times 3 times 3 times 3 is 81. All right, I do it that way because I know that. I know the 4th root of 81 is 3. Now, be careful because I don't have the answer yet. All right, I still have this radical. Now, even though there's no number, all right, even though there's no number, what is out there? All right, no, what's out there? A 1. All right, but watch what happens when I change that 9 to a 3. Everyone see I changed it from 3 instead of 9? Everyone see that? But I wrote 3 squared because 3 squared is 9. Yeah, everyone see that? No, you don't agree? 3 times 3 is 9. Okay, so now watch how I write that. 3 to the 2/4 power. So I went back. I went back to a fraction exponent. Please stop saying the letters. Right? I made it clear. It's the 5th time I'm saying it now. Please stop saying letters. Right? We know it's one of the letters. Stop saying them. Okay. So do you see the 2/4? Can you reduce that? To 1/2. All right. And if you were to change that back to a radical, you would write the square root of 3. So the answer is D. So I'm just showing you that when you see that 1/2 power, that's the same as a square root, right? The index is 2, and the number out there is 1. Now, no, what you need to know is here, can you go from the original problem to one of these? If you can do that, you're fine tomorrow. Everything else, all right, that's why this was on the review, because this is very difficult to see, but everyone see how to go the first steps. All you need is the first steps. Everybody okay? All right, number 5. Now, there's not really going to be like one like number 5, but I want to show you because it involves some things we've been talking about with rational exponents. The key thing the reason I chose this to be on the review and not on the test is because it's asking you to do something with negative exponents. Do you guys remember what to do with that, with Algebra 1, with negative exponents? Do you remember how to make them positive? It is technically the reciprocal, but when it's in this expression like this, they just need to go across the fraction bar. So do you see how x to the negative second power is up in the numerator? When I write it in the denominator, it's going to be x squared. You see how I moved it and it became positive? Jacob, look up here. All right, so I moved it and it became positive. Watch what happens with the y. See the negative first power? When I move that, that's going to be y to the first power up top. We still okay? All right, so if you look at this y to the 1/2, I'm hoping at this point you know that anything to the 1/2 power is the same as the square root. Anything to the 1/2 power is the square root. So what is the 1/3 going to tell me down here? So what is that? It's not a square root. It is a, do you remember what that's called? It's not a third root. It's a cube root. All right, so if you look at your answer choices, I believe the only one that says that is D. Okay, let's go number 6. I'm going to post the key, so no. Number 6. Number 6. Is the radical isolated? No, it's not, right? There's this plus 4 that's on the same side. We can't do anything yet until that 4 is gone. So move the 4 over with subtraction. All right, so what is 3 minus 4? It's actually negative 1. 3 minus 4 is negative 1. Now, do you see how it's isolated?
Yeah.
Square both sides. So, Camilla, this is what we were just talking about, right?
Yeah.
We're going to square a binomial. So I have 2x plus 6 equals, I'm going to do it again. Ready? If you didn't follow on the first time, watch now. Okay? X squared is x squared. X times negative 1 is negative 1x. If you double that, you get, no, negative 2x. If you double, yes. If you multiply these, you get negative 1x. You see that? X times negative 1 is negative 1x. If you double that, Fernando, you get negative 2x. Let's see, I doubled it. Yes, times 2. All right, the last one is, what's negative 1 squared? Plus 1. No, it's doubling. It's multiplying. Times 2. Now, if you, again, Fernando, can't do that yet, just multiply this out. That's why I wrote it last time. Okay? All right, so do you see how the x squared is positive here? So I'm going to leave that alone and move my other terms over. It's a positive 2x on this side. When I move it over with subtraction, I get negative 2x, another negative 2x. That's negative 4x. Please ask if you're not sure about these numbers. Okay? It's a positive 6 here. When you move it over with subtraction, what's 1 minus 6? Negative 5. Now we're ready to factor. What are the factors of negative 5 that add to negative 4? Negative 5 and positive 1. There you go. So my answers are 5 and negative 1. All right, but before you choose C, before you choose letter C, you have to check them. All right, I'm guaranteeing you, you got to check these tomorrow. So the square root of 2 times 5 plus 6 plus 4 equals 5 plus 3. Let's see if 5 works. What's 2 times 5? 10. What's 10 plus 6? What's the square root of that? 4. So 4 plus 4 equals 5 plus 3. Is that true? 8 equals 8. So that's true. So 5 works. Okay, let's try -1. All right. What's 2 times -1? -2 plus 6 is 4. What's the square root of 4? So 2 plus 4 equals -1 plus 3. Is that true? No, that's 6 equals 2. 6 does not equal 2, so -1 doesn't work. So the only one that works is 5. Okay. I'm going to post the key. Don't you worry. All this will be on there. You can watch it again. All right, let's keep going. Number 7. Yes, I'm recording right now. Number 7. Number 7 says if a to the -1/2 power equals x, what is a in terms of x? Now, I chose this to be on the review because you're actually solving for a. All right, so the first thing I did was I changed this -1/2 to be 1 over a to the +1/2. Let me see what I did. I moved it to the denominator, but then what does it become? A positive. Now, anything to the 1/2 power is the same as what? Anything to the 1/2 power is the same as what, David? Not squared. No, not cubed. There's no 3. You're close, David. The square root. Very good. So that's the same as the square root of a. Now, do you see how the x doesn't have a denominator? Yes, you see how the x doesn't have a denominator? Make it have one. And then what have I made? What's this called? What's this called? It's not a fraction. That's what we're going to do. It's called a proportion. Proportion. All right, so we're going to cross multiply. So 1 times 1 equals the square root of a times x. Right? Just ask yourself in the future, does that really need to happen? Great. So 1 times 1 is 1, and this is x times the square root of a. Okay? So if I want to solve for a, I need to get this x to the other side. So what happens when I move it over? No, what happens when I move it over? It's connected by multiplication. How do I move it over? You got to divide. So it's 1 over x equals the square root of a. Now how do you get rid of that square root? Square, both sides. Very good. All right, so a equals, what's 1 squared? 1. And what's x squared? You did it. So a is equal to 1 over x squared. Yes, Camilla. It won't be on the test. But I want to show you variations of this radical with rational exponents. Let's go to number 8. I believe it's the last one. Number 8. Which of the following values of x will not make this true? So it's not a solution. Is the radical by itself?
No.
Yes, it is. There's nothing in front of it, nothing behind it. So let's square both sides. So you have x squared equals x squared. Guys, what does that make? It makes a true statement. All right, that means every number will work. But how come one of these doesn't? No, 0 works. What's 0 squared? 0. What's the square root of 0? 0. What's 0 squared? I'm sorry, no, that's not a square. My bad. That's just a 0. So 0 equals 0 on this one. There's only one up here that doesn't look like the others. It's -4. Here's why. What's -4 squared? You can do it. That's 16. What's the square root of 16? 4. But it's supposed to be equal to that same number. Is 4 equal to -4? No. Camilla. Why are you saying his name? What are you doing? Yes, Camilla. Yeah, like the work I did to square both sides. No, because remember, this square only gets rid of the square root. It doesn't get rid of anything that was in the radical. That's just, these are inverse functions, so it doesn't touch anything in the radical. Good question. All right, guys, we're going to